Okay, welcome back to some more exciting math. In this video, I want to talk specifically about the distance formula, as the distance formula is one of the formulas that is heavily used when trying to talk about the beginnings of circles. So the distance formula is where you are finding the length between 2 points. So you're looking at the length of a line segment. And this equation right here is the equation we use, where we have that d, which stands for distance, is going to be x squared x2 minus x1 squared plus y2 minus y1 squared. So what that means is very similar to when you're solving the slope formula, in that you have to assign which point is going to be x1, y1 and which point is x2, y2. You're going to do the same thing here. You're going to assign which point is going to be which, and then you're going to plug it into the formula. Now, one thing that I find fascinating is the origin of where the distance formula comes from. So many students don't realize that the distance formula actually comes from Pythagorean's theorem. So if we take a look at it, what I've done here is I've taken a right triangle, which is what's needed for Pythagorean's theorem, and I have slapped it into a coordinate plane. Now we have 3 coordinate places, or coordinate points that we are looking at, which is at the 3 points of your triangle here. So if we think about what those coordinates actually are, if you look at this first one, notice it's going to occur at x1 and y1. So this is actually the point x1, y1. If we look at this second point down here, notice I'm still at the same y value, but now my x value has changed. So this becomes x2, y1. And then if we come up to this one, notice I'm at that same x value, but this time my y has changed. So this point here is going to be x2, y2. Okay. So where does the distance formula come from? Well, it comes from the fact that we know triangles have 3 sides, and most of the time we label them A, B, and C, where C is your hypotenuse side. Pythagorean's theorem says a squared plus b squared equals c squared. Well, one thing we know about A is that we can find it looking at the difference between your 2 coordinate points. So in other words, A would be the difference between x2 and x1. B, which is this vertical length here, is going to be the difference between y2 and y1. So if we take these 2 and we substitute it in, notice your Pythagorean theorem changes. So instead of a squared plus b squared, now we have x2 minus x1 squared and y2 minus y1 squared. Now we all know that in order to find your c value, you have to take the square root of both sides. So in other words, if you then notice or pay close attention, this right here is your distance formula. So that's where it comes from. It's actually related to Pythagorean's theorem. Alright, now we need to use this idea in order to solve problems. So I have a couple different examples here, and we're going to be finding the distance. So the first one says find the distance between -3, 7 and 2, 11. And then write the solution as an exact answer and an approximation to the nearest thousandth. So when we talk about exact, we are talking about radical form, as simplified as possible. Approximation is talking about a decimal. In other words, pull out your calculator and actually get the decimal result. So the first thing we have to do is we have to remember that distance formula. So your distance is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Now with that, we have two coordinate points, and so you have to label them. Now it does not matter, because since each of these is squared, whichever one you choose to be x1, y1 is completely personal preference. So you basically just need to choose the one that you like the best, and it doesn't matter. I like to try and keep my variables positive as much as possible. So I would pick x1, y1, then x2, y2. And the reason for that, you'll see, is when we plug it in, x2 is going to be 2, and I'm subtracting. My x1 was negative 3, so a negative 3, and I'm squaring it. And I'm adding it to y2, which was 11, minus y1, which was 7, and square it. So here, one thing that you again need to remember is that minus a negative is the same thing as plus. So here I actually have the square root of 2 plus 3 is going to be 5 squared. 11 minus 7 is 4 squared. If we simplify these, 5 squared is 25. 14 squared is 16. 25 and 16 gives you 41. Now 41 does not reduce. So when we're talking about our answers, this would be known as your exact answer. It is a radical reduced to its absolute lowest form. Now, the way that you can find your approximate answer is to take out, say, your scientific calculator. So here I'm using the TI-36X Pro, but any scientific calculator would do. And let's see, I think you can see it a little bit better here. So essentially, when using this, you have to find where your radical button is, and so notice mine is right here. It's this little blue term that's above my x squared button. So in order to get to your menu that's on top of the buttons, you have to hit your second. Notice you get this little second that shows up right here in the upper corner of your calculator that tells you that you now are in the mode to be able to use all of these blue letters or numbers or menus that are up here. So we want to use the square root. So we're going to go ahead and hit the x squared button, and notice it puts a radical into my calculator. Of course, every calculator is different. And so here we want to take the square root of 41. Okay. Now, some calculators allow you to just hit enter, but notice this one has what's called math print. So what it's doing is it's giving me a radical answer. What I actually want is the decimal answer. So in order to do that, if you have a math print calculator, is one, you would go into your radical, but here notice kind of down here, a little bit hard to see, this button right here, this is wavy lines. The wavy lines means approximate. Of course, F to D is meaning fraction to decimal. So we're looking for the decimal part, which is the wavy line thing. So in order to make that work, means we have to press this button first. You get these kind of two little double arrows here, and then you can go ahead and hit enter. Whoops. You always want to make sure that you error out of your radical. So let's try that again. You're going to go ahead and hit your little double arrows, and then when you hit enter, notice you get a decimal here. Okay, so again, real quick, If you do this and you get a syntax error, it means you probably put your change inside your radical. Just simply remember to error outside of it, and then do it and it'll push it through. Now here we want the nearest thousandths. Thousandths is 3 decimal places, so you would count 1, 2, 3, and thus that 3 stands in your thousandths. So here my approximate answer would be the little wavy lines, and then we have 6.403, and that's your approximate answer. So when you're asked for both, that is what we are asking you to do. And so this one here is the approx answer. Always make sure that you give however many decimal places as is required in order to answer your question. Okay? Now, the other example I wanted to look at is what happens if your information falls on a circle. So here it says that you still need to find the distance. But what it's telling you is that you have one point, so the point 0, 1 is on the circle, and it has a center at the point -3, 5, and the question wants you to find the length of the diameter. Well, the first thing that I would do is I would draw myself a little circle so I can actually see what it is I'm doing. I'm going to input my center, so the center is at the very center of your circle, and I'm going to label it with a C just to keep myself straight, and that is the point -3, 5. And then I have a point on the circle, so I'm going to go ahead and give myself a point on the circle, and this is at the point 0, 1. So when I'm going from my center out to this point, I'm going a distance, and that distance is a very special name. This here would be called your radius. Now, I'm going to show you why that's important to remember as we get towards the end. So the first thing we have to do is we have to find the length. So we need to find the length using the information we have. So this time we're finding the radius using the distance formula. So we're going to go ahead and start that formula. We need to decide which is going to be x1, y1. So it really, honestly, it doesn't matter. So I'm going to go ahead and say x2, y2, x1, y1. And then I'm going to put my information in. So this, remember, is x2 minus x1 squared plus y2 minus y1 squared. So inputting into my formula says that I'm going to go -3 minus 0 squared plus 5 minus 1 squared. -3 minus 0 is a -3, and then 5 minus 1 is 4. Still got to square them. -3 squared is 9. 14 squared is 16. 9 plus 16 gives you 25. And then when we take the square root, we get 5. So, what we actually found here, notice I had labeled it radius because that's what we were. We were doing just half the distance. Your diameter is actually the length that would go from one side through your center all the way to the other. So what does that mean? Well, that means when we're looking for your diameter, we have to look at twice the radius. And this is just a rule that you have to know. It's not usually a rule that is given. This is just considered to be a rule that you have to know in terms of circles. So please do not forget it, that your diameter equals twice the radius. Well, what we found here was the radius. So to actually answer our question, your diameter equals twice times the radius that we found, which was 5. Therefore, my diameter is actually 10. And this would be the answer that we were looking for. If you wanted to be really exact with your problem, you would actually then state that the length of the diameter is 10 units. And we call it units because at no point in the problem did we actually give it a unit measure. So that is everything that would get you started in terms of the distance as it relates to either giving you the coordinate points or having it come from a circle. So if you have any questions, please let me know. Otherwise, as always, remember, math is bananas. So try to keep smiling, have lots of fun with your math, relax, and I'll see you next time.